The MiG-41 is being developed as a successor to the MiG-31, which has served for decades as a long-range, high-speed interceptor. The need for a new platform arises from the limitations of the MiG-31's airframe, engines, avionics, and sensor systems, which, while advanced for their time, are not capable of countering the next generation of high-speed, high-altitude aerial threats. The MiG-41 aims to operate at extremely high altitudes, potentially in the near-space region, and at speeds exceeding Mach 4. This requires an entirely new approach to airframe design, propulsion, avionics, materials, and operational doctrine. The airframe is designed for high-speed, long-range missions. Its length, wingspan, and height make it considerably larger than the MiG-31, allowing for larger fuel capacity, which is essential for extended missions at high speeds. The aircraft's design balances aerodynamic efficiency at supersonic and hypersonic speeds with the structural strength required to withstand thermal and mechanical stresses generated during prolonged Mach 4+ flight. The airframe is expected to use advanced composite materials and heat-resistant alloys, especially in leading edges, nose sections, engine intakes, and the upper fuselage, which are exposed to extreme temperatures from friction with the air. Special coatings and surface treatments are likely applied to reduce drag, thermal load, and radar signature. The propulsion system is one of the most critical aspects of the MiG-41. To achieve Mach 4+ cruise speeds in near-space operations, the aircraft will likely use a new generation of engines derived from the Izdeliye 30 series, capable of high thrust while remaining efficient at high altitudes. In addition, there are proposals for mixed-cycle engines combining turbojet and ramjet or scramjet characteristics, allowing the aircraft to transition from standard jet propulsion at lower speeds to hypersonic propulsion in upper atmosphere flight. This allows it to intercept targets at extreme ranges quickly, reducing reaction time against high-speed threats. Thermal management for engines at these speeds is a major design challenge. Advanced cooling techniques, fuel as heat sink, and possibly active thermal control systems are expected to be integrated to prevent overheating of the engine components. The MiG-41 will carry a sophisticated suite of avionics and sensors. These include long-range radar systems capable of detecting and tracking multiple targets at extreme distances, even in electronically contested environments. The radar will be paired with advanced electronic warfare suites to detect, analyze, and evade threats, while also providing targeting information for long-range intercept missiles. Sensor fusion will allow the aircraft to integrate information from radar, infrared, optical, and electronic intelligence sources, creating a comprehensive situational awareness picture. These systems are expected to support high-speed engagements against very small or stealthy targets. Operationally, the MiG-41 is designed for extreme flexibility. Its primary role is interception of advanced high-speed aerial targets, which could include reconnaissance platforms, hypersonic weapons, and high-altitude aircraft. Its long operational range allows it to patrol or respond across vast regions, while its high-altitude capabilities make it capable of reaching altitudes well beyond conventional interceptors. The MiG-41 is also expected to operate in a partially autonomous or optionally unmanned mode, enabling it to perform missions without putting pilots at extreme risk during prolonged hypersonic flight. This dual capability increases operational versatility, allowing the aircraft to perform long-duration patrols or high-risk intercept missions. Armament concepts focus on internal carriage to preserve aerodynamic performance and reduce radar signature. Long-range air-to-air missiles are expected, optimized for engaging very high-speed targets at extreme distances. Some missile concepts include multi-stage propulsion and advanced guidance systems, designed to operate in thin air at high altitudes and maintain maneuverability at extreme velocities. The aircraft is also expected to carry electronic countermeasure pods or directed energy modules to disrupt or destroy incoming threats at range, enhancing survivability during interception missions. There is also discussion of limited engagement capabilities in near space, such as targeting objects in very low orbit, although these functions are secondary to the primary interceptor role. One of the most important challenges for the MiG-41 is thermal management. Prolonged hypersonic flight generates extreme heat, affecting the airframe, engines, and onboard electronics. Advanced cooling methods, such as heat-absorbing fuel systems, heat-resistant composites, active thermal radiators, and airflow management, are being integrated into the design. Even the onboard electronics and avionics must be hardened to operate under continuous high temperatures, including specialized enclosures, advanced heat sinks, and redundant systems to prevent failures during long-duration high-speed missions. In terms of industrial and programmatic factors, the MiG-41 is one of the most ambitious aircraft development programs in modern aviation. It requires breakthroughs in metallurgy, aerodynamics, propulsion, avionics, sensor fusion, and materials science. While the design has been finalized, translating this into a fully operational production aircraft will take years. Prototype testing, engine development, avionics integration, and structural validation are all technically demanding. Production timelines may extend into the late 2020s or early 2030s, depending on resource allocation, industrial capacity, and successive technology maturation. The MiG-41 program reflects a strategic emphasis on high-speed, high-altitude aerial defense. Its combination of extreme speed, long range, advanced avionics, dual manned-unmanned operation, and sophisticated armament systems makes it capable of defending against future generations of high-speed threats. It also demonstrates a clear shift in aircraft design philosophy, prioritizing operational reach, hypersonic performance, and extreme altitude interception capabilities. The aircraft is not just a replacement for the MiG-31, it represents a fundamentally new approach to long-range interception, focusing on survivability, speed, and flexibility in a rapidly evolving aerial environment. The MiG-41 is also designed with operational sustainability in mind. Maintenance, logistics, and mission planning must accommodate the stresses imposed by hypersonic flight in high-altitude operations. The airframe and engines are designed for extended service life, with modular components for rapid replacement and upgrade. Avionics and sensor systems are expected to allow software-based upgrades without major hardware modifications, keeping the aircraft relevant over decades. Operational doctrine envisions using the MiG-41 for layered defense, long-range rapid response, and high-speed reconnaissance missions, potentially in coordination with other strategic systems. The MiG-41 is a highly ambitious, technically advanced aircraft, intended to redefine the role of long-range interceptors. Its development represents a synthesis of extreme speed, long-range operational capability, near-space flight potential, dual manned-unmanned operation, advanced sensors, and long-range armament. The program addresses the need for a platform capable of countering next-generation threats while maintaining operational flexibility, survivability, and strategic reach over vast regions.